Chapters 7a and 7b on solving single-step and multi-step equations. In this chapter, you'll learn the essential basics for understanding, surviving, and solving basic equations, and different written techniques for solving equations. The written technique is quite essential for algebra because as the problems become more difficult, without a proper writing technique, you'll find them impossible. So here's a few key basics. When you see a term written like this, 6y, first of all, the number in front is called a coefficient. The letter right behind it, the y, is called a variable. And together, side by side, a coefficient directly next to a variable means they are simply multiplying. And this dot right here is another way of expressing multiplication. In the next expression, you see that the 6y is there again, but this time you have something added to it, a plus 1. So when we break this apart, it really means 6 times y plus the 1. Then you have an indice, 5 to the power of 4. Usually what students tend to think is this means 5 times 4, but actually that is wrong. What it really means is you write down the 5 4 times. 1, 2, 3, 4, 4 times. And then you actually multiply it. So 5 to the power of 4 is actually 625 because 5 times 5 times 5 times 5 makes 625. And finally, when we have a variable with an exponent or with a power, x to the power of 3 is just x times x times x, we actually can't have it equal to anything because, well, we don't actually know what x is until we actually solve for it. So in the meantime, we just leave it as x to the power of 3. Now, another essential basic that will help you in this chapter is remembering your integers. Remembering what happens when we multiply positive numbers with positive, negative, and negative, positive, positive, and a negative and negative when we divide, and so forth. So there's two sets of rules, one for multiplying, one for adding and subtracting, and they do two different things, so be careful to not mix them up. Basically, when it comes to multiplying and dividing, the rule is when you're multiplying or dividing by the same type of number, positive, positive, or a negative, negative, it always results in a positive answer. If you're multiplying or dividing by a positive and a negative, or a negative and a positive, essentially those two will lead you to a negative answer. And that's the theme for multiplying and dividing integers. Now, when it comes to adding and subtracting integers, it's another completely different set of rules, and that's why it's important that we don't mix them up. Basically, we think about combining numbers. When we think about a negative and a negative, it's going to make a bigger negative. So if we look here, -7 and -9, it's going to make a bigger negative. When we combine positives, so for example, just 2 plus 4, it's going to make a bigger positive. That's going to make 6. Now, the complication is when we combine opposites. Subtracting, so what we have to do is we actually have to look at this as 4 and -15. Think of it as 4 negative 15, and essentially we subtract. 15 minus 4 is actually negative. It's going to be 11, and since the negative is bigger, it's going to be a negative sign. -17, positive 18. Well, we have to subtract 18 and 17 to make 1, and since the positives are bigger, it's a positive 1. And when we get two signs in the middle, we have to essentially combine them into a negative and turn it into a -9. And so, or if we get two negatives, that combines together to make a positive 10. So we actually have to remember our rules for integers when it comes to algebra. And if this is something that's confusing, it's recommended that you revisit a tutorial about integers. Okay, so let's first think about our algebra. So we have this first expression, 3x plus 8 equals 29. What this basically means is 3 times what number plus 8 is going to make 29. So think about it for a moment. What plus 8 will make 29? This probably has to be 21. So if we know 3 times some number makes 21, what is that number? Well, that means that number, x, has to be 7. So can you apply this just basic thinking technique to solving the second problem? Pause. Now in the second problem, let's break this apart. So 5x, 5 times what plus a 10 gives us negative 25. So clearly if we think about 0 plus 10, that's going to give us a positive 10. That's still too big for negative 25. So we actually have to dive into the negatives. If we work with negative 10 plus 10, that's going to give us 0. So we have to go further. Negative 20 plus 10, that will give us negative 10. Negative 30 plus 10, negative 20. So this in the end has to be at least worth a negative 35. So 5 times what number is going to give us a negative 35? Well, I know that 5 times 7 will give us 35. But since I want a negative, I have to make sure that 7 is negative to make a negative 35. So therefore, x is equal to negative 7. Now, the inverse technique, there's 2 other techniques when it comes to solving these problems. And we've done these before, so now I'm going to just show you how the written technique works. And this is important for more difficult problems. So while these problems might seem basic, it's important that you master the written technique. So the inverse method is basically doing something to one side that you do to the other. Because algebra problems are like balance scales. If you have 10 pounds here, you're going to have a total of 10 pounds here in order to keep the scale from tipping. However, if you have, for example, 20 pounds here and you have 5 pounds here, clearly the scale is going to tip. Or if you had like 40 pounds here and you had 3 pounds here, the scale is going to tip towards the heavier end. Algebra is about keeping balance. You want both sides to maintain equal all at the same time. So if I took off 5 pounds from this side, I'm going to make sure I take off 5 pounds on this side in order to keep the scale from tipping. This is algebra. It's a giant scale. So this is how we talk about the inverse method. It's about keeping balance. What you do to one side, you do to the other. So, in this case, I don't know what 3x is exactly. My goal is to actually save x to be the last thing I touch and work for. So I want to get rid of things I clearly know. Like I know that 8 is, well, it's 8. So I'm going to subtract the 8 from this side. And if I do something to one side of the equal sign, I'm going to do it to the other side of the equal sign. So if you subtract 8, take away 8 makes 0. So that leaves me with 3x plus 0. 29 minus 8 will leave me with 21. Now that's 0. We actually don't have to write it there. It's unnecessary. We can just simply write it as 3x equals 21. Now, here we go. We have to, since we know that 3x means division, what we have to do is divide. So we're going to go ahead and divide by 3 because that's how we need to get the x alone. We're trying to isolate the x so we can find the value of x. And you always deal with the opposite. So 3x divided by 3 is going to be x, and 21 divided by 3 is 7. So x is equal to 7. Now, on the other side, it's going to look like this. I don't know what 5x is, so I'm going to leave it untouched. However, I need to get rid of that 10. So I'm going to draw a line down the middle so I know both sides of my balance. If I take away 10 pounds, I'm going to take away 10 pounds from this side. So that goes away, and all that's left on this side is the 5x. I can write the 0, but again, like I told you, it's not necessary. However, I have to remember integers. Negative 25 take away 10, or negative 25 and negative 10 is equal to negative 35. So now, since I know 5 times some number makes negative 35, I have to divide by 5 here because I want to try to figure out what x is, and I have to divide by 5 because by doing that I can figure out what the value of x is. So I divide both sides by 5, and there we go. X is equal to -7. Now, if you didn't like this method and this was complicated for you, we're going to go ahead and do one more technique. In this technique, we're going to play opposites. So the goal again is to isolate x, is to get x all alone so that we can find out what that number is. And when we play opposites, it's like a balance scale. It's doing the same thing as all the other problems, it's written differently. Since my goal is to try to figure out the x, I need to get everything away from it as possible. And I need to combine like terms. So I see 3x and 8 and 29. I need to make that 8 move over to the other side because its like term is the 29. There's nothing, I can't combine 3x and 8. They don't go together. So I'm going to go ahead and move that to the other side. Now here's the rule. The moment it crosses the equal sign, it becomes its opposite. So you see how that's a +8? When you move it, it becomes a -8. So I will rewrite this as 3x is equal to 29 minus 8. That leaves me with 3x is equal to 21. So now all I have to do is think about it. 3x equals 21. What's x? Well, 3 times 7 has to make 21, so x is equal to 7. And there we go. So we're playing opposites. We're moving things. In the second problem, you do the same thing. I want to combine like terms. I want to keep the 5x with its by alone. So that 10, those two can't combine, but I can move that 10 over to the -25. Now, I'm going to, and once it does move, it becomes -10. So 5x is equal to -25 minus 10. And that together makes -35. And so now I just think 5 times what makes -35? 5 times 7. But it has to be a -7. And there we go. This is the opposite method. So whether you choose the opposites, inverse, or to just naturally think about it, all methods are legitimate. Eventually you want to work towards a strong written method though, because the problems will only get more difficult. And that's it.